4-7, example 3, and we're going to assign coordinates to vertices. And so now we're going to be a little more vague, if that makes any sense at all. We're not going to get numerical. We're not going to get numbers for lengths of legs in a right triangle and side lengths. We're going to be given letters. And so it's going to be a little more abstract. And so I want to show you how to make this work and kind of let you see what the pattern is behind it. Okay, let's start with, let's start here with the caution. I'm going to put a big circle around that. Do not use both axes when positioning a figure unless you know the figure has a right angle. That's going to be really, really important, okay? We want to make sure we have a right angle, and then you can use both those axes. So in letter A, we have a right triangle. And so we definitely want to use the axes to help with this. And they're telling us that we have leg lengths A and B. Okay, so let's say you decide that you want this point right here to be A, that is some number A above 0 on the y-axis. Okay, and then you want to call this one B. Now, they very well could have inverted them and put the A on the x-axis and the B on the y-axis. That very well could have happened, but they didn't. So we're going to just kind of follow through with this one and see where it leads. Now, the name of the point that's on the y-axis, that's your y-intercept, if you remember from algebra last year. You always call this, you're moving 0 on the x. So if you are naming a point on the y-intercept, your first number is always 0, okay? Then if it's not 0, you're not on the y-axis anymore, okay? So, and it doesn't matter whether it's a number or a letter. If you're trying to name this point right here, then that's 0A. And if you're on the x-axis, you move on the x, but you don't move on the y. So the y is always 0 when you're dealing with an x-intercept. Okay, I'm going to just take a little note here to remind you about that. So let's talk about y-intercepts. X is always 0. Okay? And x-intercepts, y is always 0. This is a pattern. This is a consistent pattern. This will always happen. Okay? If we put the right angle where the origin is, then the origins, you always know what the coordinates for the origin is. That's going to be 0, 0, whether you have numbers there or not. The origin is going to be 0, 0. Okay? Now, this time in letter B, they said, okay, let's do a rectangle with length C and width D. Usually when we're talking about length, we're talking about left, right, and width is up, down. Okay? So length is left, right, and width is up, down. So, you know, this point right here, they're calling that point C. Well, that is an x-intercept. That's on the x-axis. So the name of that point is logically C0. I moved to C on the x and I didn't move on the y. So that would be C0. Okay, this is point D. That's a y-intercept. So I'm not moving on the x at all. So that's 0D. Okay, notice that that's the pattern that we're following. X-intercepts, the y is always 0. Y-intercepts, the x's are always 0. Okay, of course the origin's simple. Okay, so the last one, you're like, well, what would that fourth and final vertex equal? What would I call that? Well, it's a combination. Remember how we name a point. We go out to the x, so that would be C. I went C on the x and then up to D on the y. So the name of this point is CD. So it's a combination of both the x and the y lengths. Okay? So that's how you name it. All right, now I'm going to give you a little challenge question right here. This is going to be your extra credit right here to check it out. Position a square with side length 4p in the coordinate plane and give the coordinates of each vertex. So you're going to have to draw me, just do it in a quadrant 1 drawing, okay? Remember, if we're dealing with a square, what's true about all squares? That's right, their sides are all equal. So if you know one side length is 4p, do you know them all? Yes, you do. So you're going to draw your figure just like letter B, except it's not a rectangle, it's more specific than a rectangle, it's a square. So we're going to draw as close as you can to making the sides identical, and each side length is going to end up being 4p. So I need you to name each of these points that form the square. Okay? So see what you can do with that. We're going to make that extra credit. We'll do that a +1, and we'll talk about that in class tomorrow. Good luck.